everyone, I'm Dave Thomas, and today I am building the 2-inch Lil Nuke model rocket by LOC Precision. This is an entry-level mid-power rocket, and so if you've built a few low-power rockets before and you're ready to step up to the next level, this is a great kit to do it. It's just a sport flyer. There's nothing fancy about it, no payloads, no dual ejection. It's just a good high-flying rocket. So they actually make several versions of this, so that the 2-inch is this one. It's the mid-power. They also make a low-power version that's in the LOC 1 series. It's kind of fun to build too. Alright, so let's go ahead and open this up. Now the first thing we're going to have to do, once we find all these parts here, alright, is you can either scan this QR code or go to LOC's website and download the instructions for the kit. They don't come with the kit itself. So I'm going to go do that really quick and then come back. Here's the instruction sheet. And so right here we've got our parts list. So here's our booster stage tube. Actually, it's the only stage. Alright, so this is the main body tube. It's pre-slotted. Mine's got a little bit of stuff left in it there. Okay, but make sure you empty this because a lot of the other parts may be stored inside. Alright, this is our motor mount tube. It also has stuff in it. Okay, so this is our parachute protector. Alright, we have a nylon shock cord. And then in this package we have 3 plywood fins. Okay, we have our parachute there. Alright, this is the centering rings as well as the Kevlar part of the shock cord. This uses a hybrid shock cord system, as many of LOC's models do. Okay, we have rail buttons here. And it's supposed to have a launch lug, but I don't see one. Check, make sure we've got everything. Okay, now it may be that they've just shifted to using rail buttons here instead of the launch lug. Often I'll put both on my rockets because I never know wherever I'm launching whether they have rails or rods. Okay, I'm not going to worry about it. I'll just put those on, and I may even have some other launch lugs around I can use. For the size of this, you might even be able to use a 3/16 inch. And we've got the decals here. Mine are a little mangled, but I think they'll be okay. Okay, these are vinyl self-adhesive. And so other than the launch lug, it looks like everything's here. Now this kit does not come with a positive motor retention system. Instead it assumes that you'll put your motor in the motor mount here and wrap masking tape around it. And that does work. I've done it before on my own models. But I prefer to have something a little more positive there. So I'm going to use an Estes 29mm screw-on retainer. And that's what this is here. This is made out of probably polycarbonate. But these work really well. They're also very cost effective. You get 2 of them for like 10 bucks, something like that. Alright, so I'm going to put everything away here and just leave out the parts that we needed to get started. Now the first thing we do is build the motor mount. But even before we do that, before we forget, I want to draw lines on the body tube for the launch lug and or the rail buttons. And so you can either measure the distance between the 2 slots or just eyeball it. I usually just eyeball it here. And just make a mark equidistant between 2 fin slots. Since I am going to plan on having both a launch lug and rail buttons, I'm going to do this twice, so between 2 other fins. Okay, and then you can either bring this to a door frame and mark it with that, or you can use a tube marking guide, or you can use some angle aluminum. All of those work well. This is a tube marking guide made by Estes, and it's basically just a whole bunch of straight lines at different heights. And so we can just bring that to our mark there, and then just draw this along. Now this doesn't quite reach to the end of my tube, but that's fine. It's far enough. Okay, and I'll bring it around to my other mark here. And once again, draw another straight line. Okay, now I'm going to read ahead here to where it goes to the launch lug. Okay, so they're using, taking the launch lug that's normally about 6 inches long and cutting that into 2 parts to make 2 launch lugs. The other thing you can do is just use the launch lug in a single form. All right. Okay, so they're recommending on the launch lugs, place the aft one 2 inches from the aft end of the rocket, and placing the forward one at least 8 inches in front of that. Okay. Kind of the opposite thing we can do, and let's see here. Sometimes this will tell us where the center of pressure is going to be, or the center of gravity. It doesn't look like it here. But on a lot of the LOC kits, instead of having 2 lugs, they just have one big one, and basically it's set right forward of the fins here. So they're not too picky about where it goes. My personal preference, if I'm using 2 of them, is that I'll put one right at the base here, because that maximizes the contact time with the launch rod and gives it just a little fraction of a second longer that it can become more stable. And then I usually tend to put my forward one up fairly close to the forward end of the rocket there, and that makes the rocket stronger on the launch pad. So if you have a gust of wind come up or something like that, the force of that is distributed across both of the launch lugs and not just one. All right, so I had actually purchased an assortment of launch lugs from one of the online rocket retailers. I can't remember which one off the top of my head here, but I've got different sizes. So I'm going to go ahead and place the larger one down here, and right now what I want to do is just measure where that's going to be, because we're going to do some sanding here. All right, and then I'm using a smaller one up toward the forward end. All right, and I'm going to put that about 2 inches, so I'm going to use their measurement that they used on the aft. All right, so I'll put that there. I actually ran out of line there, so it's going to be right about there. Okay, and so what I'm going to do now is sand any place that the glue or epoxy is going to end up here. So I'm going to sand, first of all, just along this line for the aft launch lug. And you don't have to do a lot. All we're doing is breaking up the glossy surface to give a better surface for the glue to adhere. Okay, we'll do the same thing up here for the smaller launch lug. We'll do the launch lugs themselves, not all the way around, just on one portion. Now if you want to make these a little more streamlined, you can cut the ends at an angle. I prefer to do that after I glue them on. Okay, and then one more place to sand here will be at each of the fin slots, because we will have some epoxy fillets here, and this will give them a better grip. And again, just a couple of strokes here. We don't need to make a big mess out of it. Okay, so now I'll put those aside for the moment and come to our motor mount tube. Now this we want to sand all the way around, and you can use anything from say 60 grit all the way up to 150 grit, just whatever you have handy. And since we don't know exactly where our rings are going to go yet, we'll just sand this all the way around. Some people like to even peel up the glassy layer that's on top. I prefer to have the layer there to add strength to it. Okay, so that's all you need to do. Again, we're just getting rid of that glossy surface. And now I'm going to test fit the rings. Now in the instructions, it has two ways to put the shock cord on. What they're talking about here is kind of like an epoxy version of an Estes type of shock cord mount, where basically they're gluing it to the side of the rocket. They also then at the end of this say, well, you can do that, or you can do it with this method, which is what they use for most of their kits. So I don't know why they're even bothering with the other one. Okay, so in most cases, the forward centering ring has a screw eye that goes into it. Right now I'm just making threads. We'll come back to this in just a moment. Okay, and now I'm just going to friction fit here and make sure that we are fitting the rings on. Now, these are just a little bit too small. And so now what I'm going to do is take some 100 grit sandpaper, and I'm going to wrap it around an old D-sized engine here, all right, which is going to be a little bit smaller than the hole. And I'll just use that as kind of a mandrel here and sand this out. Now you can either go kind of in the direction of rotation like this, or you can just sand it back and forth and go around it. Whatever's more comfortable for you. All right, and don't take off too much at a time, because we don't want these to be loose. Still not quite there. Okay, so both of those are snug but movable. Now for the aft one, so this is aft. In fact, I'm going to write on the inside of this just so I don't get it turned around accidentally. Okay, so if you're for whatever motor retention you're using, you're going to want to have this sticking out about 2 centimeters or so, or about roughly 3/4 of an inch. So let's see what we got here. Okay, about 2 centimeters down there. And the reason for that is you need to have room here for your motor retention. So if you are using just the masking tape method, so your motor would go in here, and then you wrap masking tape so it overlaps both the motor mount and the motor retaining ring here. Okay. So if you're going to do it that way, you can actually make this a little shorter if you want. If you're doing the retaining ring here, like this, you need to have enough that it fits on there, and then you can scoot this back if you like. Okay, so it's a good idea to test this regardless of the method you're going to use for motor retention. Make sure you have enough room for it. Okay, now this is also a good way for me to make sure this is straight. So I'm going to go ahead and draw a line here for my aft ring. I'll go ahead and take that off for the moment. Now for my forward ring, what I prefer to do is have it in such a place that I just straddle the two slots here. And the idea is then that I'll have my fin tab exactly between the two centering rings, and when that is epoxied into place, it's going to be even stronger. Okay, so the idea here is you want these just far enough apart that a fin goes between them. Alright, which should also mean they're just far apart that when this is installed, they will straddle that hole there, just like that. Alright, so I'm going to go ahead now, make another line here. Now this one's a little harder. Actually, I probably can use my motor mount retainer there. Alright, I'll go ahead and draw a line here. Alright, now what I'm going to do is move these back till that line is on the outer surfaces now. Okay, because what I'm going to do next is I'm going to put a ring of epoxy around this and then push the ring into the epoxy until I hit my line again. What we want to avoid is getting any epoxy in this area because if you get like a fillet here or just a blob of epoxy, that's going to interfere with where that ring, with where the fin tab goes in. Okay, so I'm going to use 5-minute epoxy for this. If you'd like a little more working time, go ahead and you can use 15-minute. I wouldn't use 30 as it just takes way too long for it to cure. So I'm going to go off camera here for just a moment and make up some epoxy and then come back. Here I've made up about 2 grams of 5-minute epoxy, and you want to have some sort of disposable barrier down here on your work surface because epoxy, once it hardens, it's really hard to come off. I also recommend wearing some form of gloves, as repeated exposure to epoxy can cause allergic-like reactions. Okay, so I'm going to go ahead and just take a little bit of this and run it around my forward centering ring to begin with. Okay, and now I'm going to, actually that was already up. I'm going to move that, kind of scrape this down here. There we go. Now I can move it back up into place until I hit my line there. Okay, and then really quickly I'm also going to put in my screw eye again. And I'm going to turn this until I've got about 1 turn's worth of threads left there. And then you need to turn it so it's parallel to the tube. Otherwise, if it's sticking out perpendicular, it's going to hit the body tube. And then here, I'm going to put in just a little bit of epoxy around the threads on both sides. Okay, and then I'm going to come up here, or down here. This is my aft centering ring. Okay, and we'll quickly put this around. Now, if you're not working as quickly as I am, you may want to have a smaller amount of epoxy and make up a separate batch for each ring, or use 15-minute epoxy. Okay, and I'll move that one up into position as well. So right where we can see the line. And then I still have a little bit left and it hasn't cured yet. So here I'm going to put some up on the tube itself. And then we'll put on the retainer ring here. Just kind of screw that on. Give it a really good contact there. Okay, and now we'll just let that entire thing sit and cure. After I check for straightness again. The epoxy has cured, and it's formed itself into some nice fillets there, so we really don't need to do any more to it. For this next part, we're going to put on the Kevlar part of the shock cord, and you're going to want some regular super glue for this. So the first thing I'm going to do is simply tie a loop into each end. About that big. Okay. Now where it's got really frayed there, I'm going to use a hobby knife and cut that away. Now keep in mind, Kevlar is used for bullet and knife proof vests and such, and so it doesn't cut very easily. That was just a really frayed area. Now I'm going to take my super glue here and I'm put just a drop or two right on the knot and then on any frayed areas there. We'll do that on both ends. And this just locks the knots into place and keeps it from fraying more. Kevlar has a very slick surface to it, and so it does not hold knots well. Okay, and then you can just take a tissue or a paper towel or something and just wipe off the excess there. We don't need big blobs of glue on it. Alright, and now to attach this, simply pass one of the loops through the eyelet there that we put on the forward centering ring, and then take the other loop, pass it through the first loop, okay, and then pull this tight, just like that. Okay, and that will hold it into place. Next, you're going to take the free end here and pass it down through the motor mount and out the aft end, and this will keep it out of the way when we go to mount the motor mount into our body tube. And for that, the first thing we'll do is just try and do a dry fit here and make sure that we're not too tight, and we are. Alright, so when you got a tight opening like that, two things you can do. On the tube, you can just take your thumbnail and kind of chamfer that edge, pushing it outward a little bit. I'm guessing this will not be enough though. We'll give it a shot. So we can try it again. It actually went in a little easier. Alright, but that aft ring is still hanging there. So again, what we'll do is just take some sandpaper here. I'm using 100 grit, and just start sanding around those rings. Okay, now we'll try this again. Alright, and that goes in without a problem. Now I'm going to go ahead and place it where I think it should be. Okay, so we should have it right about there. And we can't quite see the centering ring on either end. And so now if we take a fin, put that in, our fin tab is actually just slightly longer than the body tube slot there. And I had the same problem on another LOC kit. So what we'll do is when we do the fins, and we'll prep the fins here a little bit later, but we'll just sand a little bit on these fin tabs. In fact, you can see there where the laser cutter went in and then came out a little bit there. So that looks like maybe a little bit of a problem with their cutting program. Alright, but that's easily fixed. For now, we're going to go ahead and glue the motor mount in. And for this, you can use 5-minute epoxy. I'm going to use 15-minute just because it's a little bit stronger. And also it gives us a little bit more working time to get this in just the right position. Here I've made up about 4 grams of 15-minute epoxy. And we're going to need a little bit longer applicator for this one. So I've got a stick here. And what we want to do is first of all put a ring of epoxy, a broken ring, so in between the fin slots, but close to the forward edge, but not all the way up here. We want to be able to push that epoxy with the forward centering ring. And then before we put that all the way in, we'll also put a ring of epoxy right around the aft end, and that will be for our aft centering ring. Right. Once again, I am wearing gloves and have my protected surface here. Now you won't be able to see this very well of me putting the epoxy in. We'll try and get it under the camera. Alright, but I'm just visually looking at where I'm going here between the slots. I did get a little bit of epoxy there on the slot edges. We'll just kind of clear that out. It's a little too far, bring that back. Okay, it looks like we need just a little more up in that one. Okay, so now if I look up inside of it, you're probably not going to be able to see that, but it's right where I wanted it to be. Okay, so now I'm going to insert the forward end and just kind of hang this off to one side like this. And now I can use my other applicator here. Alright, and we're just going to put a ring of epoxy here. Now some of it just fell down onto the engine mount, and if you can, clean that type of spill up, because that will interfere with the fin tabs. Alright, so not quite as much on there at a time. Go. Okay. Now the other thing I want to watch for is, you can see the ring there, the eyelet for the screw eye. We don't want that to show up in a fin slot because it does poke through the other side. So I'm just going to turn that and make sure it's not going to be in line with the fin slot. And we'll just push this through both layers of epoxy. Alright, and then make sure that we have clearance between both rings and the fin slots. Okay. Looks like we've got Just a little bit showing on either side. A little bit of epoxy got pushed up there. I'm just going to kind of clean that out of the fin slots. Looks like my forward ring shifted during this whole process just a little bit. We'll just fix that by shaving the fin tabs a little bit. Okay, and now I'm going to put this back in. It can just sit in there for now. I'm going to raise my camera up here. Now with the remaining epoxy, I'm just going to allow this to ooze down in there. Now I don't want to get it on the threads, so we do have to be careful about that. But since this takes longer to set, we can put this in along the edges and it will flow down to make its own little fillets there. In fact, I'm going to make up a little bit more so that basically that whole outer surface of the centering ring will be covered in epoxy. So I need to make up some more. I'll do the rest of this off camera and then show you what it looks like. Okay, so here I have put the epoxy in, and it's still kind of running down into there, and eventually it will cover that entire surface of the centering ring. Now before it sets, I'm going to take a few tissues here, moisten them with alcohol, and I'm going to use this to run along the aft edge here to catch anything that's spilled over. And we did have a little bit of that going on here. Okay, so this being 15-minute epoxy, it'll start setting in 15 minutes, but it's going to take a while to cure fully. So I'm going to let this just set and cure for at least the next 2 hours. While we're waiting for the epoxy to harden on the motor mount, we can start work on the nose cone. This is a polypropylene nose cone, which makes it very strong, but it doesn't accept paint very well. And also the molding process produces these big seams here, as well as these little nubs that are part of the mold. So we want to sand those off. And to start with, I like to use between 100 and 150 grit sandpaper, depending on how thick these things are. These are pretty thick on this nose cone. So I'm going to start with 100 grit and just try and knock down as much of this excess plastic as I can. Okay, so you can see most of that seam is gone here at this point. You can see a little bit more of it on this one. And I've also taken out those little nubs from the molds. Okay, now as you can see, it makes a lot of sanding dust here. It also tends to clog up sandpaper over time. Now once we get past the initial sanding here, I will move off camera and do the rest of it underwater. And do wet sanding on that. Now I'm going to move to 150 grit sandpaper, and this I'm going to use all around. The reason for that is to give a toothy surface that paint can adhere to. It doesn't adhere to the smooth surfaces here of polypropylene very well at all. Okay, so that's a pretty uniform level of scratchiness there. And what I'll do now is take this where I can put it under running water and continue sanding this with at least 220 grit sandpaper. And then in some, depending on how it looks, I may go up to 320. It doesn't need to be polished because we are going to prime and paint this. And again, you want just a little bit of that scratchiness there for the paint to adhere. But this is too much. This will show through paint. So at least 220 grit, maybe 320 or 400, depending on your personal preferences. So I'll do that and then come back. Here the nose cone has been wet sanded with 220 through 400 grit sandpaper. You can still see just a hint of a line here. And I will probably get rid of that with the primer that I use, which is a filling primer. And that's actually going to be the next step here. So I'll hit this with several coats of filling sandable primer, sand that, and then this will be ready to paint. As to the paint, I've often had viewers ask me why I don't do what's on the labels or on the packages. And usually it's just because everybody else does those. Okay, but I am going to try and get close to this. So my plan is to paint the nose cone purple, the body tube a light gray, and then around the fins yellow. I may not do the purple and yellow here. I may just do that whole region of the rocket yellow. But it'll come up close to what it looks like here on the package. Here on the motor mount, the 15-minute epoxy has flowed nicely into all the nooks and crannies there and kind of leveled itself out. And this is what I was looking for. So this gives us a very strong mount here between that centering ring and the body tube. And it also gives us a really resistant surface here so that backwash from the rocket jet and things like that don't carbonize this so badly. Okay, so the next thing I'm going to be doing is sanding the fins, and then we'll start attaching things to the rocket. So while I was waiting for the motor mount to dry and everything there, I did prime the nose cone and then have wet sanded this with 220 through 400 grit sandpaper. So this is ready to go be painted. Next we're going to prep the fins for attachment. And somehow I managed to get a little bit of epoxy on there. I'm not quite sure how. But the first thing we want to do is take some 100 to 150 grit sandpaper and just shape the edges on this. I'm starting with some 100 grit sandpaper here on just a wooden sanding block. And first I'm just going to do the faces here. So just sand in the direction of the grain. And we don't need to do too much on the faces with this grit. When we go up to the finer grits, we'll do more. But mainly here, this is going to remove that soot from the laser cutting process. All right, and now I'm going to shape this. So at the very least, I recommend rounding over the leading edge there. And then if you want, you can round or taper the trailing edge. Or you can just leave it straight there. And it's all a trade-off between strength and aerodynamics. So if you round the forward and taper the trailing edge there, that's going to be very aerodynamic, but especially on that trailing edge, if you taper it, it's going to be more prone to chipping. Okay, so it's kind of up to you how you want to do it. As I said, I'm going to round the forward edge first, the leading edge. And to start with, I'm just knocking down the corner edges there. All right, and then frequently check in cross-section to make sure you're doing this evenly. And after you've got that edge knocked down, then we can start doing the actual shaping here. And so I'm going to make mine more of a taper than a rounded leading edge. So I'm just adjusting the angle of my sanding a little bit. And then come over to the other side, do the same thing. Okay, so come back, check again. All right, and now as I'm ready to round this, what I'm doing is just kind of rotating my wrist in here and back again. And you can rotate it all the way over. Now, some things to be aware of is just by hand holding and sanding this, you're going to tend to sand more in the middle than on the edges, and that's just because of the way the fin bends, and we tend to lighten up as we hit the ends there. And so you may need to come over onto the two ends and do a little more sanding specifically there. But you can use this line of unsanded material as a guide to help you know where the heavy sanded parts are and the lighter sanded ones. All right, and again, check the cross section frequently so you're not going lopsided there. Okay. And on mine, I'm just going to square off the trailing edge. I'll just go with the rounded leading edge. All right, and then just give a brief stroke or two here to the root edge, just giving it a better gluing surface. You can kind of get the root edges up here above the fin tabs a little bit. Not a lot of room to do that. Now, the other thing I'm going to check here while I'm doing this is to make sure the fins are going to fit in here. And if you recall, when I test fitted them before, the fin tabs were just a little bit too long. All right, and that's in part because my rings moved inward like a millimeter, and that was just enough to set them apart there. So here what I'll do is just shorten the fin tab length a little bit. And you can either do just the front or just the back or both of them. Just try and keep it a consistent length. All right, these are also acting like they're very tight just in their thickness. So we'll go ahead and sand the face a little more here. Now we'll probably have to do the same thing on all the other fins there. Now I'm going to change sandpaper here and move to 150 grit. And I'm just going to run over the whole thing again. So I'm going to do the surfaces and then smooth up the edges. Then finally I'm going to move to 220 grit. Now this is wet dry sandpaper. You can just use dry sandpaper. This just happened to be what I have handy. Alright, and then we're just going to do a nice finish to the whole fin here. Okay, that gives us a nice smooth finish. Now if you'd like, this would be a good time to use sanding sealer if you're going to use it.